So far in Access, we've done everything based on a single table database. So all of our data has been in one table. But really, to pull things forward and start to use Access's full power, we need to look at relational databases. Before we look at the relational database structure and how you build them, the mechanics really, we need to look at why and the usefulness. So if we take an Excel file I have here of some client data, and it simply has their client ID, which is the primary key, hence the little asterisk, their name, a couple of address fields, zip, country, and then the date the client was added to our system. Now we also want to hold their sales information. So I could do that in Excel. I know how to use Excel, that's great. We come along, we add another column, and we say sale value, sale date. And then our friend here, Elizabeth Johnson, goes and buys $10,000 worth of items on January the 6th, 2013. Not a problem, that works. Curtis Liu buys $5,000 worth of items on February the 7th, 2013. Now we can see that that's going to work fine. We're going to put our data in and enter the sale date. However, what happens when Elizabeth Johnson then wants to make a second purchase? It's okay, I know how Excel works. We can add some more columns in. Sale value 2, sale date 2. Now we come down, and this time she goes even crazier, $12,500 worth of items on March the 23rd, 2013. Let's just narrow those columns up a little, and these two as well. And we could go through the same thing down here, for example. Who's this chap? Wyatt Hill. He makes a purchase of $50. He only bought a little thing on April 23rd, 2013. He then makes a second purchase to go with his first one of $100 in July 4th, 2013. But then he wants to make a third purchase, so I have to come back up here and add in some more columns, which is great, works well. I know how Excel works, not a problem. And he's going to go and spend $125. He really is splashing out in October 23rd, 2013. Now this works fine in Excel. Let's just auto fit those. The biggest problem comes when we then try to interrogate this data. It's a little all over the place. If I wanted to add up the sales for a given period, I would have to interrogate the sale date fields, that one, and that one. And then the value fields, that one, and that one. And that's only if each customer made 3 purchases. If one of our customers, Elizabeth, for example, made a 4th or a 5th or a 6th, I've had to add in more and more columns. I would then need to interrogate more and more columns. Now that's not ideal, and it becomes very difficult, and I've got to restructure my Excel file every time I do it. So anything that's looking at the Excel files, such as a pivot table, has to be renegotiated and rebuilt. Also, anyone who doesn't make so many purchases has a lot of empty fields. So all these cells are empty and therefore wasted. Not necessarily in memory space, because our computers are now bigger and bigger, but certainly in time for each of our interrogating queries to go through all those empty fields. So what we have here is related, but it's not directly related data. It is data that belongs to each of the people, but there's multiple repeating values. What we really ought to do is extract this information into a separate table. So we can do that, for example, in a new sheet, call that sales. And in this particular new table, we have a sales ID, so that each of our sales has a unique reference, sale value that we already know, sale date. And because we're now storing the sales data separate to each of our clients, we also need a client ID. That way, what I can do in here is take that particular sale, store it in my sales table, and make sure that I attribute it to the correct sales client, which is 3. So I just use her primary key here as a reference, but that sale becomes our first sale. Our second sale, this one here, goes in there, belongs to client number 10. So this sheet, in this case, it will become a table, now only gets a new row when we make a sale. So we don't have all those empty spaces that have to be interrogated. Plus, all the sales values are in one column. So much easier to interrogate and manipulate and use mathematical functions on. All the sales dates are in one column. So again, so much easier to manipulate, find date ranges, look at particular years. And if we want to know who bought a particular item, we use the ID of the client to go back to the client table and have a look for that client. And there we are, Curtis Liu. So here we have related but multiple value data. And really it's only when you get into designing database that you will figure what falls into that bracket. Things here where we would have to continue restructure the main table to get the items to fit. Where there's lots of blank fields. In our sales table, there will be no blank fields. If nobody makes a sale, they don't get an entry in the sales table. It's as simple as that. Whereas if we try to store everything in one sheet, we end up with lots of empty cells. So that's the first reason for having multiple tables. The second reason for having multiple tables doesn't come from all this redundant space and extra columns. It comes by actually looking at the data itself. If we pick on the client country column, for example, we have down here, we only have 100 clients, but between them, they probably only cover 4 or 5 countries. So there's a lot of repetition in this column. Where you get repetition, what we could do is save some memory space. Every bit of memory space you save speeds up queries in the future by replacing the country names with numbers. Numbers work much faster in database systems. So instead of saying Eugene and Christian Elizabeth live in Australia, we say they live in country 1, for example. So this is a new table where we store our countries separately, country ID, country, and we might have country number 1 could be USA, country number 2 could be UK, country number 3 could be Australia, country number 4 could be Canada. And then in our client table, we replace the relevant countries with the correct ID. So this is our country sheet. Australia is 4. There's a lot of Australias. Just replaced the United States there, that's 1. Actually, Australia's 3. Replace all the 4s with 3s. Now, you wouldn't be replacing existing data. You would build the database in the first place to take the IDs, not to take the actual text values. So having to do it retrospectively does take a bit of time, but if you design it right in the first place, you wouldn't be doing this data replacement. And if you were doing this data replacement, you would, in reality, do it with a find and replace, not with a manual adjustment of each item. But there's only a few, so I'm going to just run through them very quickly. Luckily, there's only a few. Even a few can take some time. So once all your client countries are then numeric values, to see what country people live in, we need to do a little bit of a lookup. We take the 3, go to the country table, come down the country ID, and find that 3 is Australia. The beauty here is that you're saving space in the database, because instead of Australia repeated however many times, we simply have the number 3. You're speeding up querying, because numbers work so much faster than text values, and you've only got the word Australia stored once in the database. So if it's spelt wrong or needs changing, we just change it in one place, which is the country table. So my one table, which could be quite large, becomes 3 tables. And in fact, if you looked at your data, you may wish to change one of the other columns to one of these little country type tables, a lookup table. So I have a 3-table database. Now, just as we designed a single table by drawing up the structure outside of Access first, we would do the same with our 3-table database, so that we have TBL clients, TBL sales, and TBL country. Within each one, we have a primary key defined, so each table has its own primary key. So that's the reasoning behind having multiple tables, rather than one big flat sheet like Excel.